Hey guys, welcome back. In our last video, I taught you guys how to find a critical number, and now I'm going to show you why critical numbers are so important. Okay, so I'm going to pick up from the two examples that I just did in my last video. So we have a function called x squared minus 4x minus 5. It's a parabola. We know that it's going to open up like this. Okay. First, what we did was we found the critical number by taking the derivative, that's this part here, setting it equal to 0, that's this part here, and solving for x. We found that x is equal to 2, and that's a critical number. Now, what I'm going to do is I'm going to make a number line, and I'm going to label that number line f prime of x, okay? Sometimes teachers, what they do is they name it f prime without the x, and that's fine also, okay? What you're going to do, you're going to lay the critical number down, okay? And if you have more than one critical number, like we have in our next example, then we're going to put those down, okay? So you put down the critical number. Remind yourself that a critical number is where the derivative is equal to 0 or undefined. Now, we are going to pick a number in this interval. So what number should we pick that's less than 2? 0 always makes sense. Now, what you're going to do is you are going to figure out what f prime of 0 is. But let me explain to you why. F prime of 0, or f prime in general, tells you the direction of the function or the slope of the function. So in this case here, f prime is this right here, okay? Maybe I should have picked a different color. That is fine. This is f prime, okay? What is f prime of 0? If I put a 0 into this, I get 2 times 0 is 0 minus 4 is negative 4. I don't really care what the value is. All I care about is the sign. So my sign is negative, okay? So that means that my function is decreasing all the way to 2. Now let's pick a number that is after 2, which is 3, okay? You could pick 4, 5, you could pick a million, it doesn't matter, but I'm going to pick 3, okay? We're going to plug the 3 back into the derivative. That's why it's important to put this here so you can know where to plug it in. 3. So by you plugging in 3 here, you get 2 times 3 is 6, minus 4 is 2. 2 is positive. That's all I care about. I do not care about what the value is. So basically what happened here was my function decreased from negative infinity to 2, and then it increased from 2 to infinity. That's amazing. Why? Because if you go all the way down and then come up, what happened at 2? Well, 2 is what we call our minimum, right? It's like you went down, then up. So you ended up hitting the bottom, which is a minimum. This is what we call a relative minimum, okay? But I need to know 2 comma what? Well, sometimes they ask you just for the x value, but now I want to find out the y value. Remember that this here is our graph, okay? So this is where you're going to figure out where the points go. So you need to plug the 2 back into here, okay? Because this is where all the points are. So 2 squared is 4 minus 4 times 2 minus 5. That's going to be about negative 9. I hope I'm right. Okay, so your minimum is 2, negative 9. If you think about this parabola, what you just found was the vertex, guys. You just found the vertex or the turning point. So this parabola will decrease. Take a look back at the picture that I drew in the very beginning. So this parabola will decrease until 2, negative 9, okay, and then it'll increase. So that's how we find the relative min. And actually what I'm doing is a section that's 2 sections down. I'm also showing you where it's decreasing and increasing. I just feel like it all makes sense to do it together. Let's try one more problem, okay? Here's our problem here. This right here is our original function. This here is our derivative. This here we set equal to 0, and then we solved. And what is this called again? are critical numbers. How do we find our critical numbers? We take the derivative and set it equal to 0. There can be more than one critical number. So now I have more than one. Okay, what do I do with this critical number? I'm trying to find the max or the min if there's any. Okay, so what I need to do is I need to put a number line, put my f prime of x, put 0, put 1. I need to then pick numbers in between. Okay, where am I going to plug these numbers to check for the sign? F prime of x. What's f prime of x? This is the key, guys. This is the most important thing I'm going to teach you in this video. This is f prime of x. But this is also f prime of x in factored form. Why is that important? Because you don't have a calculator. So it's extremely important to say, hey, do I plug it into the top one or the bottom one? Okay, it'll give you the same answer, but sometimes it's easier to figure it out when you have it in factored form. So let's try it. I'm going to pick the number 2. So what is f prime of 2? Okay, well, I don't care what the number is. I just want to know the sign. So 2 squared is, I'm going to plug it into the factored form. 2 squared is 4 times 12. Okay, that's positive. 2 minus 1 is 1. I don't care about that, but that's positive. So a positive times a positive is a positive. Let's try negative 1. Okay, so what is f prime of negative 1? Well, negative 1 squared is 1 times 12. That's positive. And then what's negative 1 minus 1? That's a negative. Positive times negative is a negative. And now we need one more here. So what's between 0 and 1? Okay, 1/2. Sure. Well, 1/2 squared is positive times a positive is positive. 1/2 minus 1 is a negative, right? Half minus 1 is negative half. Positive times a negative is a negative. So it would have been much harder if you tried to plug it in to the unfactored form. So that's why you can plug it into here or an easier way because you won't have a calculator. All right, so what happens here? My question is, what is the maximum or the minimum? Well, let's take a look at the graph. The graph starts at negative infinity, then it decreases, then it decreases again, and then it increases. So only here does the sign switch from negative to positive. Therefore, there's only one extrema, and it's a relative minimum. Why? Because you went down and then you went up. So the relative extrema, there's a minimum at 1. 0 is just a critical number, but he's nobody. He's not a max nor a min. The graph went down, stopped for a second, and then went down again. Then it came back up. So 1, okay, x equals 1 is our relative min. And now I want to find the value, okay? So I'm going to erase some of these. So x equals 1. And remember, you have two places. Where should you plug it into to find the value? Do you plug it into f prime or do you plug it into f of x? This is our graph, okay? You got to plug it into here. So if you plug 1 in, 3 minus 4 is negative 1. So there's a relative min at 1, negative 1. Okay, so we're going to do some more. Also, the graph decreases up to 0. The graph decreases from 0 to 1, and the graph increases afterwards. Remind yourself that all the intervals, so decreasing, it's going to be from negative infinity to 0 and 0 to 1. You got to stop it. It's open interval, okay? Do not say from negative infinity to 1, because at 0, it stops, okay? And then increasing is from 1 to infinity. All of these are open brackets, okay? So that's pretty much it. So come back for the next video. We'll try some more examples on max